Hi friends, in this session we study about the mensuration. In mensuration we study about the properties of triangles. So in triangle, you see a triangle is one of the basic shapes in geometry, a polygon with three corners or vertices and three sides or edges which are line segments. A triangle with vertices ABC is denoted by triangle ABC, or in other words, a closed figure consisting of three line segments linked end to end, or a three-sided polygon is called the triangle. Or the word triangle derived from Latin word tri means three, and the angulus means corner or angle. So it is the triangle word which derived the Latin word. Now explaining a triangle here. This is our triangle. We are putting some name to the vertices or the corners. This is our A vertex, this is our B vertex, and this is our C vertex. We have to always denote the vertex with the capital letters of English alphabet, and the side opposite to the vertex is denoted by the small letter. Side BC, which is opposite to angle A or the vertex A, is denoted by small a. The length of side BC, and the length of side AC, which is opposite to the vertex B, is denoted by small b, and the length of side AB, which is opposite to the vertex C, is denoted by small c. So this is the terminology we have to use in triangle. So as per the definition, you see here is the polygon with three corners. So there are three corners ABC, or the vertices we say, three sides AB, BC and AC. We have the three sides or edges which are line segments. This triangle is called ABC, or we could mention this by triangle ABC in this way. Or in other words, if you classify this, if you define this, a closed figure consisted of three line segments linked end to end. So there are three line segments here, you see. In other words, a closed figure consisting of three line segments linked end to end. So here see the three line segment AB, BC and C are linked end to end, AB, then BC and CA, or it is the three-sided polygon shape according to this. So we could write they are the component we have components we have in this triangle: vertex A, or we could say the angle A, angle B and angle C. These are the vertices or the angles, and other are the sides, side AB, BC and CA. These are the line segment, or we could say AB is C, AB is C, BC is A and CA is B. So in this way we could classify the triangle. Now I explain the properties of triangle. First, you see the first property we have to see about the vertex. The vertex, the plural is vertices, is a corner of the triangle. Every triangle has three vertices. So I explain you here the vertex A, vertex B, vertex C. These are the vertices A, B and C. Now we talk about the base. So base, you see the base of a triangle can be any one of three sides. Usually the one drawn at the bottom, you pick one any side you like to be the base. Commonly used as the reference side for calculating area of triangle. In an isosceles triangle, the base is usually taken to be the unequal sides. So here you see it is an obtuse angle triangle. So here if I put the name, give the name to the vertices A, B, C. You could take any either of the side as a base. You could take BC as base, you could take AB as base, and AC is also base. I explain later in the altitude. So here also if we see ABC is here, So it is an equilateral triangle, so you could take any side as a base, and altitude would be corresponding to that, which is 90 degree on that. So here you see another one. I explain you, here is ABC. It is an isosceles triangle, that this side is equal to this side, so always we have to take this side, the unequal side should be the base, as in the isosceles triangle the base is usually taken to be the unequal sides. So here the unequal sides, so this would be the base. So this is the base for this. So now I explain you the altitude. The altitude of a triangle is the perpendicular from the base to the opposite vertex. The base may be need to be extended, as in the obtuse angle triangle we extend the base. I explain you now. Since there are three possible bases, there are also three possible altitudes. So here if I explain you, here if you have to find out the altitude, if we are taking the base as BC, we are taking BC as base. BC, I change the color first. BC as base we are taking, and we have to find out the altitude of the opposite vertex. The opposite of BC, the vertex is A, so we have to extend this base first. So we will extend this base up to here, and we draw a perpendicular from vertex A on this extended base. So this would be the perpendicular. This is our D point, we could assume here. This is our D point. So the base would be BC and the altitude would be AD. AD would be the altitude. So this is the altitude we have. AD is altitude. Here in equilateral triangle it's very easy. So we just draw a altitude from opposite vertex on this BC. So if we assume BC as base, this would be AD would be the altitude here. If we assume AC is base, we could draw in this way 90 degree, and it is C would be the altitude, which is 90 degree on AC. And if we draw in this way, so you see here it is CF would be the altitude and AB would be the base. So in this way we could find out. I explain you this obtuse angle triangle other way also, coming on that matter just now. Here you see in ABC we are taking, always we have to take it would be better if we take the unequal side as a base. So we draw this here. So this is our AD is our altitude and BC is our base here. Now in obtuse angle triangle you see we have taken here the base as BC. Now we take the base as I write down here the name. This is the A, B and C. Now we are taking the base as AC. So we draw a perpendicular from the opposite vertex, which is B. So this would be like this. So this is BD would be the base, and AC would be, sorry, here you see the BD would be the altitude and AC would be the base. So in this way you could find out. Other way we also have one more. We have taken base this, now we take base this one. So what will happen, we have to see. So if we take base this one, so we have to we need a perpendicular from this place. So we expand this up to some extent and draw one perpendicular from here. This is our ABC, we already know that. Sorry, A, B and C, and this is our D point. So the AB is base and CD is altitude. So this is our altitude now. So in this way we could draw the altitude from the opposite vertex of the base corresponding to the base. Now I would like to explain about the median. Now I explain you about the fourth property, which is related to the median. The median of a triangle is a line from the vertex to the midpoint of the opposite side. The three medians intersect at a single point called the centroid of a triangle. So here first I give the name to these vertices A, B, C. These are the vertices of a triangle. Now I draw the medians from each of the vertices to the opposite side, the midpoint of the opposite side. So I give the name to the opposite side, that this is the midpoint. So just a moment, this is the midpoint, this is our D point, this is the midpoint of AC, this is our E, and this is the midpoint of AB, which is F. So I draw a line from A to D here. So I draw a line here, A to D. This is our median. First median we have drawn here. The second median I am drawing from B to E. Look at here. And the third median I am drawing from these C to F. So look at here, all the medians intersect at a common point. The medians at a single point. So here you see that they intersect at a single point. This single point is called centroid, or we could denote it by any letter, because ABC we have already taken, so we could denote this by G. So G is the letter we are denoting for centroid. So this is the G point, and this is the medians. Now I would like to explain about the interior angles. The interior angles of a triangle, the three angles on the side of a triangle at each vertex. The interior angles of a triangle always add up to 180 degree. So we see this is our A, B, C, the three angles, this angle plus this angle plus this angle. The sum of all angle is 180. These are the interior angle, because the inside of a triangle it's obtained. So angle A plus angle B plus angle C is equal to 180 degree. This is another property. We will prove this in our later sessions. Forthcoming sessions we see. These are all things. The exterior angles, we see the angle between a side of a triangle and the extension of an adjacent side. The exterior angles of a triangle always add up to 360 degree. So here you see this angle, that is a side, the adjacent side, the angle between the side of a triangle and the extension of an adjacent side. So side of a triangle and the adjacent extension of the adjacent side, this angle, then this angle, then this angle. So these angles are exterior angles, and the sum of these all exterior angles, first I give the name to this. This is our A vertex, this is our B vertex, this is our C vertex. So the angle A, B and C we have to find out. This is the A exterior angle, recording exterior angle. If you see, exterior angle A, exterior angle B, exterior angle C is equal to 360 degree. So this is the way to find out. It is always add up exterior of angle A, exterior of angle B, exterior of angle O, always 360 degree in any sort of triangle. This is our last one. Also, the shortest side is always opposite with the smallest interior angle. Look at here, the longest side is always opposite to the largest interior angle. It is, we have a triangle ABC, and it is an right angle triangle. I just like to explain you this. So angle B is the largest angle in here, and the side opposite to this is the, which is the hypotenuse, is the largest side in the triangle. And this angle A is a acute angle, which is the smallest one in this triangle. They see the length of this BC is the smallest one here, and this is the middle one angle, which is greater than angle A and the smaller than angle B. The length of this side is between the length of the side BC and AC. It is the middle side here. So I explain you here. So angle B is greater than angle A. So opposite side opposite to angle B is AC, is greater than side opposite to angle A, which is BC. Similarly, if I write down angle C is greater than angle A, so the side opposite to angle C, AB, is greater than side opposite to angle A, which is BC. And finally we see if angle B is greater than angle C. So look at here. So side opposite to angle B is AC, which is greater than side opposite to angle C, which is AB. So this is the property we have to follow in triangle. The shortest side is always opposite the smallest interior angle, and the longest side is always opposite the largest interior angles. So this we have studied in this session. Thank you.